The law of sines, algebra 2, trigonometry regions. So the law of sines is a reference sheet formula. Flip to my reference sheet for a moment. The previous lecture was law of cosines. I'm sorry, it was area of a triangle. And law of sines is below it, below the difference of two angles. Here's your law of sines. The law of sines, along with the law of cosines, these are your two tools that you can use to find side and angle measurements in triangles. So let me just draw a quick picture for you. So if we have a triangle like this, and say I know this is 5 and this is 7 and this angle is 26 and I want to know what this angle is, I can use the law of sines to find this angle measurement, and I'm going to talk about that in a minute on how to do that. But sometimes the question comes up, why can't we use just basic trig? Well, if I had a triangle, if I had a right triangle, or this was a right angle, and I wanted to know what this was, and I had like a, a 7 here and a 26 here, then yes, I could do just basic trig here. I could say that tangent 26 equals x over 7. I could cross multiply, and I could get x right there. So you could do just basic SOHCAHTOA trig stuff that you learned in ninth grade to find missing sides. And if I wanted to find the missing angle, you can do, inverse tangent and stuff like that, second tangent, all that stuff. But those basic trig laws that you learned years ago, they only work for right triangles. So you need a 90-degree angle in order to do that basic stuff. This triangle that I drew here, there's no 90-degree angle. This is not 90 degrees. This is not 90 degrees here. So that's where the law of sines and law of cosines really comes in, is that they allow us to solve for a missing side or angle. Now you need certain information around it. And we're obviously going to spend 3 days, 2 days on law of sines and a day of law of cosines, and then another 2 or 3 days just kind of practicing them together. Because depending on what you have, like if I have two sides, depending on where the angle is, I could use law of sines or I could use law of cosines. So depending on what you have, these are available to you. But if it's a right triangle, you could use all basic stuff, but it's not going to be a right triangle. So first of all, the law of sines looks like this. Now, they show you all three fractions here as a proportion, all three ratios as a proportion. But you're never going to write the law of sines as all three of them. What we're really trying to say is that any two of these are equal. A over sine A equals B over sine B, and B over sine B equals C over sine C. So that means that A over sine A equals C over sine C, because they're all equal. So you're really going to, for the most part, be writing just a proportion with two of them and cross multiplying and stuff like that. If I draw a quick little picture of triangle ABC, here's angle A, would make this side A. We'll call this angle B, that which makes this side B, and we'll call this angle C, which makes this side C. So notice that the lowercase letters on top, side A plus B, these are sides. And sine A, sine B, sine C, these are the opposite angles of those sides, right? Because what's opposite side A is angle A. What's opposite side B is sine B, or angle B. And what's opposite C is angle C. And then we're doing sine of the opposite angles. So sine of the opposite angles from those sides. So you create a proportion, and we'll create a ratio, which equals another ratio, which is a proportion. And you solve that. Let me explain this a little more in this next example. Now, does it have to be A, B, and C? Can my triangle be H, Q, and R? Absolutely. That would just make this side H, this side Q, and this side R. And it'd be R over sine R, H over sine H, Q over sine Q. So, it's not always lettered, and it's not always lettered numbered at all. But anyway, so it's just a side over, so any side over sine of its opposite angle equals another side over sine of its opposite angle. So in triangle ABC, and you don't have to draw the pictures for these every time, but I'm going to do it just to help out a little bit. So we'll call it A, B, and C. Angle A is 35. Angle B is 82. Side A equals 4. What is the length of, well, I put that 4 in the wrong spot. Side A is opposite angle A, would be 4. And what is the length of side B, which is opposite angle B here? So I could create fractions. I could create ratios, which will then create proportions. That this 4 is opposite this angle 35. That's A over sine A. So 4, a side over sine of the angle opposite. Sine of the angle opposite equals. I'm looking for side B. That's my variable. That's my unknown. But it's opposite 82 degrees. It's opposite angle B. So opposite sine 82. And what I have here is a proportion, because it's a ratio equals a ratio. I have this number, I have this number, I have this number, I do not have this number. Now, in order to properly solve a proportion, we need 3 out of the 4 pieces. I have 1, 2, 3, and this is my unknown. I can cross multiply here. Now, the reason why I point that out is because in order to do the law of sines, you need what I call a complete set, or a complete pair, a complete ratio. See, I say I was missing this angle here. Could I cross multiply? No, this would be an unknown times an unknown. So you need at least one complete set, meaning this fraction right here, I have side A and I have angle A. That's my complete set. Is I have a side and the angle across from it, so I can do law of sines. Like hypothetically, if this problem, say this 82 was here. Well, actually that would be okay. Like say this 4 was here. Let's do that instead. So I have this side 4, but not the angle across from it. I have this angle, but not the side across from it. I have this angle, but not the side across from it. I cannot do law of sines. Now, in this particular example, I could just find this third angle because I know the 3 of them adds 180, and then that would be my complete set, 4 over what this third angle is. And there are going to be problems where you have to do that. But it's all about, you need a complete set. You need a side and an angle measurement across from it. You need both of those so you can create a complete ratio, complete fraction, which you can use to cross multiply with an incomplete fraction. All right, so back to this problem now. All right, so now that I have, 3 out of 4 pieces here, I have, sorry about that. Get rid of that. Oh boy. Let me just tap on that and erase my complete set circle there. So now that I have 3 out of 4, I can cross multiply here. And what gets cross multiplied is 4 times sine 82. And these are in degrees, so make sure your calculators are on degrees. And b times sine 35. B times sine 35. And it's just a little bit easier to always put the side in front of the sine angle. So 4 times sine 32, 4 times sine 82 is that, and then to solve for b, I'm going to have to divide by sine 35. So then I'll be dividing by sine 35 to solve for b. And again, just type that into my calculator. So now my answer divided by sine 35, and it's 6.9, which is the nearest tenth of an inch is 6.9. So b equals 6.9. But once you have this ratio, the calculator will do a lot of the work for you. But let me do one more example for you quick. Okay, so here we have triangle ABC. I see I have angle A, angle B, side A. What is the length of side B? Again, I have a complete set. I have an angle A and a side A. So that's going to be the side over sine of its opposite angle. So 10 over sine 45 is my complete set. Once again, I'm finding B here. And sine B is what its opposite, and that would be sine 30 degrees. And this is one where if I just type this into my calculator, 10 times sine 30 divided by sine 45, it's going to give me a ratio, a decimal which I can compare to these. But the fact that I see radicals here means that this is probably an exact thing. And what do you know? These are special angles. You know, they kind of stand out, right? So 10 over sine 45 is rad 2 over 2. And b over sine 30. Sine 30 is 1/2. So 10 times sine 30 is 5. And then I would divide by a radical 2 over 2, which is really easier thought of as multiplying by the reciprocal 2 over radical 2, right? And then I can express this as 2 times 5 times 2 over rad 2 is 10 over radical 2, which I can rationalize to be 10 rad 2 over 2, and then simplify the 10 over 2 to be 5 radical 2. So you might have a little bit of a radical algebra to play with there. Like I said, I could have cross-multiplied it and then checked these answers with my decimal, but if this is not multiple choice, say this is a part 2, then this is what I would have to do there. But the question would say that special word exact if it were a part 2, telling you not to round. So always be on the lookout for that word exact. All right, but it's basically find that complete set it equal to an incomplete set, cross multiply, and go from there. So not too bad. All right, see ya.